The ones I've seen that are fairly successful are the ones that have really nailed down the new construction side. So they're basically designers, project managers, supervisors, and of course raters, and they get involved in making that work. A fairly niche market. Usually it's for the pretty high end advanced homes, but there's quite a few of those guys that sort of float around the industry. And the energy audit has always been a problem residentially, and we knew this early on. Is that the problem is fundamentally homeowners have problems. They do want to buy solutions, but they don't like paying for information. We figured that out 50 years ago now.
Welcome to the Flow Lab, the podcast where we dive deep into the science of building performance and HVAC innovations. Today we bring you another insightful episode aimed to enhance your knowledge and expertise in the field. Joining us are your co-hosts, Ben Walker, co-CEO of Retrotec, and Sam Myers, a renowned building science specialist and Retrotec trainer. Together, they bring a wealth of experience and knowledge to ensure our discussions are both informative and engaging. So, sit back, relax, and get ready to enter the Flow Lab, where we'll explore the world of building performance. Let's get started.
It was great having them on here, and that's for sure. It was cool to get some insight onto how things really started. And it's interesting that started as a chimney sweeper out of high school or whatever, and like the accidental entrepreneur he calls himself. It's kind of cool.
Yeah, I feel like Brendan's story is one that's just not heard very often. When our longtime customers have gotten to know Colin over the years, but not many people realize that it was really like Brendan that kicked it off and then kind of brought Colin on, who was in there for the long haul. So I think it's cool too that he was fixing houses, as a weatherization contractor. And then, realized he needed some airtightness testing tools after he discovered that it was a thing. And then, we just need to make some of our own. And then it kind of kicked off from there. So I think it's really cool that we started with weatherization, and then we're still really supporting that industry heavily still today. So kind of
That's awesome, man.
supporting the roots that we started with.
Brendan's kind of maybe the man behind the curtain per se, maybe, but always interested and still is in home comfort and IAQ issues and all that kind of stuff, really. So it's great to get a chance to talk with him. For me, it's been a long time since I had the chance, whatever. So it's nice to catch up.
Yeah, it was really the first time I'll get to catch up with him at all. We've kind of pinged back and forth over email. I think we've been on the phone a couple of times, but I'm glad he's still really active in the industry and doing his thing.
Yeah, awesome. Well, I hope you guys enjoy the episode.
Mm-hmm.
Okay. See, here's the
Oh, look at that.
Probably can't be, but even the Retrotec beer from
I see that. Oh,
Bob.
Look at that. Love it.
Yeah, Ben and I are not perfect podcasters yet, so we will definitely be editing this up.
Yeah, exactly. Lots and lots of post-production.
Still getting our feet wet.
I think that's probably always a good idea. I mean, think about it from the standpoint of the listener. They don't like seeing that, that the sort of 50 minutes, and they have no idea whether it's going to be 50 minutes they'll never get back in their lives and they'll regret, or whether it's going to be worthwhile. So you don't want to develop a reputation early on of being long-winded and boring,
No, exactly. And
that's what my point, Sam, I don't think you were on yet, but my one concern about quite a few of the questions was that they're kind of like inside baseball between like you guys and maybe some of the owners that might be interested in bigger issues of business and partnerships and things like that. I suspect most of the Retrotec audience is going to be more intrigued by the fact that the first blower door I used was 14 feet long.
Oh, wow.
And what the reaction was of the first homeowner that I did a smoke test for, and how that made me go, there's something interesting here, So,
that's awesome.
Yeah. I think a lot of listeners will be happy just to hear about just, how this all began.
Yeah.
There's still so many contractors that are just brand new to building science, home performance, whatever you want to call it in general, and just saying like, oh, wow, this has actually been around a long time, and just hearing how some people just kind of stumbled into the industry. Some people, came to it from the academic side. So, of all the people that I've met, there's all kinds of angles where you can come from to get into this.
You bet. Yeah. Absolutely. Well, I guess, how do you want to kick it off? I mean,
I feel like we kind of already have, really, with the beer.
Yeah, really. That's a good way to start, huh?
Sam always goes to the BSS, what are building and science and
the BS and beer chapters.
Yeah, so it fits right in, really, right? It's like
Well, at the Affordable Comfort Conference, which they changed the name to the Home Performance, whatever it was. But I remember way back
HVAC
in the
for
day
what?
that we always had an evening, a beer evening, where people would bring craft beers from all over the country, and we'd find a meeting room to hang out in. So yeah.
But we are curious though, like you mentioned the 14-foot blower door. Was that like the first time you'd ever seen one, or like did you make that yourself, or?
Yeah, so I've been accidental in a lot of things in my life, and my first thing was I'm an accidental businessman. I had a entrepreneurial seizure or a capitalist convulsion when I was in high school, and started a chimney sweeping operation.
Oh
So
wow,
the
okay,
top hat and tails, and
yeah.
and that very quickly got into selling and installing wood stoves, and that got into working with some people on solar greenhouses, passive solar additions, and we did workshops and all that stuff. And through that, I met actually my first partner, and also actually technically a co-founder early on of Retrotec, which is Sebastian Moffat.
Oh sure, I know
And
Sebastian. Yeah,
yeah, so Sebastian and I met up through friends in the whole energy field, and we had this bright idea that we could start an energy auditing business. And it was back in 1979 or something. I think I was 18 years old, and I brought to the table my youthful enthusiasm and a little bit of sort of entrepreneurial ability. And Sebastian was much more formally educated. He had a BSc in I think environmental science or something, but he'd been employed by the National Research Council and the Energy Mines and Resources, which is now Natural Resources Canada, to do research on home weatherization stuff. And he'd written the book called Keeping the Heat In, which is sort of the and a Bible. That was sort of the homeowner Bible on how to conserve energy, and then a manual for insulation, one of the first manuals for how to do you know, advanced weatherization. So he'd already been exposed to a lot of the cutting edge building science and house as a system knowledge, and I just ate it up. He was my mentor originally,
oh wow.
and that's how we first really got into all this. And we started the energy auditing business and realized pretty quickly that the most common question people would ask would be, who can we hire to do this
The work.
insulation, this air sealing, this
Yeah.
put a new furnace in, whatever. And that's still a very perennial question. I think, Sam, you've probably seen that right in your work.
Yeah,
So
that's very common.
so anyway, that was we very quickly realized that people would pay us to be project managers, and we started that way, charging as a consultant project managers, and then very quickly realized, well, the contractors will give us 10, 20, 30% if we
Mm.
just sell it and sub it to them or arrange it that way. So within just literally months, we transformed from being an energy auditing business into what I think is probably, you could call it the first home performance contracting business in North America. I can't think of anyone who was doing what we did any earlier than us.
Wow.
And actually our first employee was a heating and air conditioning service technician. His name was Larry. He was an oil burner tech, and we hired him because Sebastian was a member of a fuel oil co-op. And the co-op was a group of homeowners, quite a large group, that had been organized to bulk purchase and negotiate with the oil companies to get a deal on fuel oil. This is back before we all converted to natural gas in our area. And so we managed to wangle an agreement that we would be the provider of all the tune-ups and service for this group of few hundred homeowners, to do the yearly and oil needed service. That does get kind of dirty. And so our first employee was actually Larry, and he was with us for quite a few years. He finally quit because we asked him to do too much duct sealing.
Oh really? Oh no.
Oh
And
yeah.
that is also a recurring
I
theme in our
understand why.
industry. Yeah, it's like you ask a technician to go down in the hierarchy of heating and air and do duct sealing when he's not doing service and installs, he'll quit
Not a
on
happy
you.
guy.
He was not happy.
Yeah, well,
Anyway, so that
so this
was
is
how
like
we got into it. And but obviously, around that same time, Sebastian had already heard of the blower door concept in his work, and it was on our radar right as soon as we became partners. And we felt that if we were going to offer to do instrumented energy audits, is what we called them at the time, that term originally came from the Princeton house doctor program from Princeton University. The Center for Energy and Environmental Studies had a project called the Twin Rivers Project in the late 70s, early 80s that identified and really was the first really good documentation of the whole concept of a thermal bypass.
Mm.
An attic floor, we can go up into the attic and you pull the insulation bat aside and you can drop a football all the way down in the basement.
Yeah.
That was not something people knew about back then.
Yep.
Wow.
Yeah.
Yeah. So we said, we're gonna have to get into get one of these blower doors, but you couldn't buy one back then. And so, through our contacts at the National Research Council, the first blower door that we ever used was one that was owned by the National Research Council that they had built a few years earlier sometime in the mid-'70s. Bob Evans was the project manager, one of the engineers there. And that's just right here in Ottawa, where I live,
Okay.
Ottawa, Ontario. So we asked if we could borrow it, and he said, sure. And then on the day that we were supposed to get it, he called and caught us, and he said, how are you planning to transport this? What kind of vehicle do you have? And I had a pickup truck, so he said, oh, that's good.
Yeah, with a trailer, maybe like the.
Yeah.
Almost. So we get there, and we literally we understood the concept. What it was 2 7-foot pieces of pipe, 16 inches in diameter, with a 16-inch DC inverter powered, really high end motor.
Yeah.
That had very good speed control, and a bunch of liquid manometers, incline manometers.
Oh, sure.
For the pressures. So I think we were just using the Dwyer manometers. The one with the little red
Yeah.
liquid
yeah.
pixel.
Yep.
And they had electronic stuff from, I think, Visalia and whatever, but they wouldn't lend us that stuff. To get electronic transducer manometers back then, they were kept in the lab.
And it was so long because it probably looking for laminar flow. It had like flow strainers and stuff in there before it went to an orbit.
Exactly. It had honeycomb panels in there, and pitot an averaging tube system, cross averaging, and they had the calibration curves well defined. I think they might have just been based on velocity. I think we had to do the velocity conversions with each reading, but it was designed to have very clean airflow. So the other problem, though, he said the other reason we needed a pickup truck was because he said we got like 4 or 5 panels of plywood to fit all the doorways that we've kind of found so far, but you might have to go to the hardware store, the lumber yard. We didn't have Home Depot back then. You might have to go to the lumber yard and get another panel if the door you're trying to put it in don't fit. So literally, we would take these pieces of plywood that would have a 16-inch hole. They had holes all the way around the perimeter of the 16-inch hole in the plywood to line up with the flanges on the pipe. The pipe had welded flanges on it. And we'd have to laboriously bolt.
Yeah.
We'd have to put a bolt with a nut on each one of these,
Oh, man.
and then bolt the 2 pieces together, and then bolt the whole thing to a fan. And if you were doing a depressurization test, we could put it in frontwards or backwards, but usually there isn't 15, 16 feet of straight run in a hallway. So we often had to stick it out the front door.
Oh, man.
And then figure out. Then there's a porch, right? So then you had to stack it up. But anyway, we had that was the best airflow. We got calibration we had for quite a few years. It was anyway. So just to summarize all that, that was the first blower door test, and I think I was pretty good at math in high school. I didn't go any further to college. I meant to, but I got distracted by business. And so Sebastian and I our first really big investment in tools was a Hewlett-Packard graphing calculator. That sucker was like $500. It could do regression analysis and coefficients and so on. And $500 in 1980 was a lot of money.
Oh, yeah, for a calculator, yeah.
And then we had log paper, graph paper, logarithmic paper. And so we would take all these readings, and, the test would take, half an hour to take all these. We knew we had to do multi-point testing. No, you don't. But back then we thought we did.
Yeah.
And so we'd take all these readings, we'd run it through the calculator, we'd plot it all out, we'd draw the lines, and it was all cool. And I remember distinctly, Sebastian's wife, Patty, was in the house while we were doing all this. She was just like, whatever, boys and their toys. No real interest.
I think exactly.
But I have to say that when we pulled out our smoke puffer, at that time it was not a nice new Retrotec air tracer. It was back then we used. It wasn't even a titanium tetrachloride smoke puffer. It was sulfuric acid based.
Oh, wow.
Made by Draeger in Germany. So these little Draeger smoke tubes, you had to crack the glass vials and then put a puffer on it, and that stuff was rank. It was worse than titanium tetrachloride.
Oh, man.
But it was good smoke. And anyway, so we pulled this out and we said, well, let's go and see if we can find some leaks. And we found some pretty interesting leaks. And Sebastian calls Patty. He says, Patty, come over, take a look at this. She came over, And I swear, she was like, "Oh, let me see that." And, "Oh, check over here. Check over here." And we went over the house and she was complaining how the house was so cold and drafty in the wintertime. "Oh, is this why?" And, we're looking at all this stuff. So, and I said, I was born at night, but it wasn't last night. And I said to myself, there's something to this, but not
Yeah.
from a technical standpoint, just
It's making
purely
it visible.
Yeah,
the
yeah.
first homeowner, we made an invisible problem visible. And, the fact that she had a such and such square foot hole in her house, which, equivalent leakage area was sort of how Canadians looked at things back then. So that was that she got that, bigger than a beach ball of combined holes. That made sense to her. And that I think really triggered my belief that this diagnostic technology of all the things that we do and that we did, have done over the last, whatever it is now, 40 some years with Retrotec, it is premised on the fact that we're making the invisible visible.
Yeah, exactly.
Yeah.
And
Like,
anyway,
So with that blower door setup back then, how long did it take you from start to finish to complete a test?
you'd have to allow over half a day
Yeah.
for sure.
Just for setup and
yeah.
everything, and like, yeah.
Yeah. So now around that time, I think after we did that test, we went down to Princeton, Sebastian and I, and visited the Princeton Center for Energy and Environmental Studies. Ken Gadsby, Gautam Dutt, Dr. Harji, and they had a blower door. And Ken Gadsby, actually, we just discovered at that time, was selling a blower door at that point.
Oh,
his
really?
own make.
Oh,
But they were
wow.
giving away the plans. They're employed by the university, so we had the plans from them for their blower door, and it was using some Granger Dayton, motors and things like that, and Magna Helix, and we used that as a basis for our first design at Retrotec. We're trying to use RPM calibration. That was their original blower door, was calibrating the fan. It was an axial fan to RPM versus pressure.
Yeah.
Really bad sidetrack to go
Yeah.
down that route.
Yeah.
And so it was, and that was actually what led to Colin getting involved with the company, which I can explain here. So, so that's sort of the initial history was this energy auditing business became, by default, we stumbled into building our own blower door. It sort of worked. And we had acquaintances in the industry. I think Seb and I had an article on us in the New Shelter magazine. It was a Rodale publication that got us a lot of attention. A lot of people contacted us, said, "Hey, you built blower doors. Can you build us one too?" And so we started making these things in the basement of the office, an old heritage building we were in. And we had the guys who were doing our weatherization. One day they'd be spraying rim joists, and the next day they'd be building a blower door, and by hand. And each one cut, with my old table saw, and we were using plywood panels, and we had a few
Wow.
custom machine screw parts put together. Pretty horrible. I think.
Oh, is the shell made of fiberglass back then, or some other material?
Yeah, that was all laid. The first design was for the inlet was a laid up fiberglass. What we ended up doing is we were able to calibrate the fan at high air flows reasonably well. I mean, probably plus or minus 10, 15%.
Yeah.
But the low air flow, we fortunately, Rob Dumont at the Saskatchewan Research Council, I believe Rob might have been Harold Orr, but one of those guys had come up with about a 4.5-inch bell mouth nozzle.
Okay.
And that thing was about, I recall it was around 100 millimeters of diameter at the throat, and it was maybe 2-3 feet long. And so we, whenever we were under, I'm guessing somewhere around 600-800 CFM, we would attach this thing with an adapter to the front of the vane axial fan.
Oh, sure.
And
Okay,
that was a
reasonable.
kludgy way to do it, but we did that for a few years to get really accurate low airflow. Anyway,
What do you guys use like for a reference device back then to like verify that the airflow that you're calculating through the fan was the correct amount?
traceable, of course, with liquid incline manometers are traceable as long as they're calibrated. It's just they're not a lot of precision. So we did have I think it was a Visalia manometer that we bought, an electronic transducer. I think that was the brand.
But then,
And
like,
it's
for the flow measurement, do you have like your reference device was like another orifice plate or something, or
Yeah.
like a
That's
machine
well,
like
well,
that?
actually, yeah, I think let me sort of bring Colin into the story then, because Sebastian and I had no knowledge of this other than what we could pick up and read from. There was some ASTM stuff out there. The people at NRC were basically saying, we like what we got. 16 feet's not a problem for us. We wanted
Oh, it's like,
2 feet, not 16
Yeah.
feet.
yeah.
And so we kind of went down the approach of what Ken Gadsby had done. down in Princeton, but it was a struggle. And I ran into Colin. He was an acquaintance of mine because he was a living a few years before that. He'd been a housemate of one of my girlfriends at
Oh,
the
wow, okay.
time. And so we knew each other socially. And that was when he had actually a clothing manufacturing company called Cream Jeans.
Yeah,
And
exactly.
yeah, so that was, so he was
Cool
a
to
pretty
know,
cool
exactly.
guy. And I was like 17, 18, and he was like 30 or something, right? And he had a really cool early 60s, I think it was a Beaumont or something. It's beautiful blue convertible. Yeah, so he's a pretty cool dude. And so, we were friendly and went to a lot of parties and stuff. Anyway, he disappeared for a while. It turned out it's because he sold his shares in the clothing
Creator.
company and went off to go sailing in the Pacific. And then he migrated back to Ottawa. He was, sucked back to Ottawa at some point a few years later. And so I ran into him. I go to this solar energy
Yeah, that's what
public
he was
meeting.
saying too. Yeah, that's what he's saying. That's where he met up with you again. Yeah.
Yeah. So he was in the audience. I was in the audience, and on the way filing out, we run into each other, and we catch up, and he makes some comment about solar being kind of like nice concept, and I said, well, I kind of agree. We're doing energy efficiency, basically, reduce before you produce. This is kind of
Oh,
the
yeah.
concept, right?
Yeah, yeah.
And so,
Yeah.
and explained to him what we're into, and he was very interested. And so we connected within the next few days, and I think Sebastian was still involved in the company then, maybe less so because he moved on pretty quick. But we came to a deal where Colin had an instrumentation technology diploma, like a 2-year program, and he was good at math. He was familiar with calibration.
Yeah.
So we said, well, why don't you help us out with this calibration thing? So we agreed on, a few $1,000s for him to come in for a few weeks to help us figure out how to calibrate. So I think we ended up calibrating it on calm days in the back office with cardboard in the window. That's that was
Wow.
but we couldn't do it if there was any wind movement.
Oh, man.
Anyway, that didn't work out perfectly, but he at the end of the agreed amount of time and for the amount of money that we had budgeted, that bastard just hung around.
I know you can't get rid of him.
Couldn't get rid of him. He kept working for free and being useful. It was awful. So yeah, and after I'd say probably about 6 months of that, Sebastian had moved on to his scientific research side of things, and it just made sense for Colin to be an equal partner in the company. So we came to an arrangement on that, and then we were partners 50-50 until I guess 1998. So about another 16, 18 years, something like that. So that was the sort of the original genesis of it. And at the time, for a little while, probably 6 months to a year, we had 3 businesses all connected to the same basic
Kind of
field.
core product, or yeah.
Yeah, operating in the same building in this office downtown Ottawa. It was basically the weatherization, auditing business was still going. I was doing most of that. My partner Sebastian had gone kind of back into the whole research with the Canadian government
Yeah.
side of things, and so we got contracts that a lot of them with Canada Mortgage and Housing on airtightness in buildings, and that was useful to have the blower doors. That's when Don Fugler was involved. Don, if you remember, Don was the head of the CMHC's research division for quite a few years, and he was an engineer and was actually a volunteer or a poorly paid daycare worker at Sebastian's daycare. And Seb got a contract and offered Don a position, and that's how Don got into the whole
Oh,
building
wow.
science field.
Oh,
I
man.
ended up running the whole CMHC research division. So he and Seb did a lot of great work with combustion backdrafting and negative pressure problems, and they actually built a powered flow hood,
Oh, wow.
which is basically a duct tester.
Yeah.
For part of that research with Siltair Scientific, working with Canada consultants, and I'd heard through the grapevine that when Gary Nelson heard about that and saw them present on it at a conference, that's what gave him the idea of building the first duct blaster.
Oh, really? Oh, wow.
Yeah.
Okay.
So it's kind of like Sebastian built the first duct tester. Gary launched the first that was really the duct blaster.
Yeah.
And then, Retrotec, we came along with ours a few years later than that.
Yeah.
So that's kind of we're all a bit incestuous back then, I guess. But yeah, actually, there's that was a fun time to be around because we had those 3 businesses, the research side of things, the auditing, and the blower door manufacturing, all kind of in the same, operation, and a lot of cross-pollination going on. But it became clear that that Retrotec was a good opportunity, and so we decided to shut down the auditing. Actually, I sold its name and assets to one of our clients, another contractor in town. Sebastian actually moved out west around that time.
To Vancouver
and
then.
to Vancouver,
Yeah.
and Colin and I focused 100% on Retrotec from then through till about 1998 together. And
Where did the name Retrotec come from, really? Like, what was it?
it was, I think Sebastian and I were knocking around. We figured out retrofit technologies.
Okay, yeah.
It was
Yeah.
all-encompassing enough that we could use it to do other things in the retrofitting field. But even though it ended up always being, as you guys know, in the instrumentation
Yeah.
side of things.
Yeah.
Yeah.
And lots of new construction is really where it's used in now too. So it's not all just retrofit anymore. It's
Yeah,
well,
just to meet
exactly.
code.
Yeah,
Yeah.
and actually that's part of what happened right around that time. I think one of the questions we'd knocked around before coming on the show here was, what was the market like back then for this technology? And for sure, our first clients were eggheads.
Yeah.
And I think we were like, hey, yeah, we're mano a mano here. We're all the same. So we had energy auditing guys. We had people wanting to do new house testing, engineering companies, energy rating, which always to me seemed like a solution in search of a problem. But the point is, it was all super technical, and the Canadian R2000 program was launched around that time to encourage energy. And I was a member, founding member of the Canadian General Standards Board 149 committee, which is the airtightness testing of buildings, and representing that side of things. Also, that's when David Somm from Virginia with Infotech.
Sure, from Infotech, yeah.
Yeah, he hit the market around then, and he was a member of that committee. Rob Dumont was on that committee, and a whole bunch of other NRC. Bill Jones from Ontario Hydro, he built a blower door, but it was a blower window.
Oh, wow.
His little guy was, he had a calibrated fan he would put on almost a card table, and then he ducted out a piece of foam board cut in to fit in a window. And for testing a new, tighter home, that actually was fine. It was kind of like using a duct tester and a cloth frame that we do now.
There's a company in Japan that actually makes a similar device.
Yeah.
It hooks up to a window, to a duct. Yeah.
I got a fair bit of involvement with the R2000 program, doing a lot of testing and training guys and providing equipment to them. I remember testing, probably the tightest home we tested was a home that Oliver Drerup built for a fellow named Brian Toller. And it was in, I think, 1982, 0.5 air changes at 50 pascals using, at the time, what I call the Black Death and plastic bag technique, which is Black Death being acoustical sealant. And quite an achievement for him to get it down that low. Now, Aero Barrier, which now I'm a big fan of Aero Barrier and Aero Seals.
Oh, yeah.
Aero Barrier does that routinely now. They get down
Yeah.
to 0.1, 0.2.
It's amazing stuff.
It's wonderful.
Yeah, it is.
Yeah.
But I have to say, Aero Barrier, thinking back, going back now to the early 80s, Aero Barrier vindicated Joe Stebrick in a big way. Because Joe Stebrick, he's always been obstreperous and foul-mouthed, but he got into real trouble at grand poobahs of the Canadian building science community because he was so pig-headed about it's a dumb idea to build houses out of plastic, and trying to make a 6 mil poly to be an air barrier.
Yeah.
And the clarity that an air barrier and a vapor barrier don't have to be the same thing. Whereas it somehow, I'm not quite sure how, but the plastic with acoustical sealant overlapped kind of was the way it was done, and it had been forever. And Joe was very vociferous about, no, the smart way to do it is to make the drywall, the air barrier on the inside skin, and at least in a cold climate, and caulking and foam gasketing and various other processes. And he basically, to my interpretation of it, he got so fed up with the eggheads and the intransigence of the Canadian side of things that that was a big impetus for him moving to the States.
Oh,
Yeah.
wow.
Moving to
Really? No
Boston.
way.
Yeah.
But
Yeah.
the thing is, Aero Barrier is confirmed that the Aero Barrier applied when the drywall is on is becoming I wouldn't build a house any other way now.
Oh, yeah.
How would you?
Yeah. It works.
Yeah, and
Yeah.
you can get those levels of control. So anyway, that was all a lot of fun. But anyway, that was sort of the early days, and then what happened is we started finding other people that were more profit oriented, wanting to buy blower doors. Basically insulators that were more advanced. Solar guys. There's a big push in the States. There was an early tax credit program that was in place for quite a few years, and we managed to convince a bunch of solar guys they should also do a day of house doctoring as part of a solar job. as as a way to add value.
Yeah.
In fact, that's a very common application right now of AeroSeal. AeroSeal is routinely done as a bundled solution to make the solar work better.
Yeah,
And
to
the
get like
package,
better results or your net metering or something like that. Then like
yeah,
yeah.
yeah, the same idea is get the load down, optimize the size of the panels, but it's also a way to, in old school tin man talk, spike the deal. One of the challenges in any in-home sale is that if it's a big ticket, you can't do it right away. The client might get buyer's remorse and
Mm.
back out of the job.
Oh
And
yeah.
so what Danny DeVito and Richard Dreyfuss would do back in the Tin Man movie, by the way, great movie for sales. It'll make you puke, but a really good movie. But those guys back in the '60s, they came up with this concept of starting the project the
Mm.
next morning after someone was
Oh
sold,
wow.
and make the customer not want to back out.
Yeah.
Well, that's the more evil interpretation of it, but it is a good fit for anytime you have a big project to be able to start something
Yeah.
and
Start
get
showing
some.
progress right away.
Well, it's partly to show the customer that they made a good move to buy from you, right?
Yeah.
And that's the thing and the AeroSeal done well, by a well-trained crew that really knows what they're doing. It's impressive, to have
Oh yeah.
that the guys come in and be able to show that certificate that shows 90% plus reduction in leakage. Very scientific, and so I really encourage anyone that's adding AeroSeal to heating and air or to solar, if they can't do the main job right away, get in there and do something to show that the
Good
client made a
value.
good
Yeah.
move
Yeah.
and they're getting value. Yeah.
So
So
going back to like when you were first talking about how you got into this and especially starting the energy auditing company, there's still a lot of those today. Whether if you want to call them energy auditors, HERS raters, building science consultants,
yeah,
basically what they offer is some type of diagnostic testing and reporting, and then prescribing a solution, but they're not doing the actual work
yeah,
to do that. So I feel like even today, that's still an issue with a lot of these companies. Some of them do really well. Some of them are struggling a
it
little
is.
bit more. Some of them are relying on government funding whenever that releases. Like here in the States, we had it in the mid 2000s with the ARA funding. Then we just had it again recently. I don't think that's a sustainable way to do it. I think there's
Well,
better ways.
not with the new
But
administration. It's probably not going to last. No.
yeah, that's definitely about to run up. But for these companies that do this energy auditing, HERS rating, energy analysis, I mean, what would be your recommendation for these companies to kind of
Well, I
thrive
think
a little bit
they're
better?
certainly the ones I've seen that are fairly successful are the ones that have really nailed down the new construction side. So they're basically designers, project managers, supervisors, and of course raters, and they get involved in making that work. A fairly niche market. Usually it's for the pretty high end, advanced homes, but there's quite a few of those guys that sort of float around the industry, but it's a niche market. It's not the mass market, and the retrofit market, like I said, the energy audit has always been a problem residentially, and we knew this early on, is that the the problem is fundamentally homeowners have problems. They do want to buy solutions, but they don't like paying for information.
Sure.
We figured that out 50 years ago now. 50, almost, yeah, almost 50
Yeah.
years ago, and that's when I realized pretty damn quick that like I could make. I remember I sold my first duct seal with a furnace my first year doing this to a client who had an audit done and they needed a new furnace and they asked for a recommendation. And I'd already decided to heck with giving this business away. And so I had a guy that was an independent subcontractor for other companies, one man installer service guy. And he gave me a wholesale type price to put a furnace in and to do the duct seal. And I remember back then it was like $700 profit I made on that, and that's in 1980, which is probably like twice that now. But it was literally I got paid to do the audit, and we were charging $400 back then to do an instrumented audit. Um, but I made more money in 10 minutes than I did spending half a day, or almost more than that to do an audit and do the report. And that's always been one of the problems. Is I noticed this a lot of times the best auditors get stolen away by the heating and air companies that can sell equipment. And
Yeah.
why would you? I know guys literally that make $1 million a year in sales commissions in heating and air.
Oh wow.
Wow.
They're out there. There's a bunch of them now. There weren't a few years ago, but now there are. But there's a lot of guys make over $500,000 a year. And you look at that, if a guy's got talent and good communication ability and he understands the technology and he's, all that, why would you want to be an energy auditor when you can be of service to people by actually delivering them what they want? Now, as long as you're representing a good company and they're doing good installs, and that's part of my mission with my More Clean Air initiative is to attract and bring together a network of the best heating and air guys that are focused on doing good quality installations, the proverbial term for it. But one of the weaknesses, though, I've seen of quality installation all these years is that everyone says they do quality installation. And so
Yeah,
from a
sure.
sales standpoint, even Joe Garage says he does a quality install. So you have to have things like Measure Quick and the ACCA, accreditation and all that to really make it actually mean something. But one weakness is that even guys that do a great job on refrigerant charge and getting all the pressures right and even getting airflow right, is that a lot of them don't do what they should be doing to address the pre-existing ductwork issues. Like they may be lucky with the airflow, or they may be able to crank up the variable speed motor to overcome it. And as long as they can get the airflow, the Measure Quick will say it's okay, even if the static pressure is running high. I've seen variable speeds working just fine up at 1.1 inches. Now, using a lot more power and making more noise and all those
Yeah.
things, but
Yeah.
it's
Kind of
actually,
defeats the purpose if everything else
Sometimes it
isn't doing
does.
what it's supposed to do.
Yeah.
but you hook that up to a leaky duct system, and that's a problem. So, it's one of the reasons actually, about 10 years ago, I think it's about 10 years ago this year, I sold my interest in Comfort Institute, which is training offshoot of Retrotec, to AeroSeal, and joined up with them full time for a few years as a retained consultant. And now I work mostly just with AeroSeal dealers, although I'll work with any contractor. But one of the things I love about AeroSeal is that it's predictable. Now it doesn't work all by itself. You usually have to do hand sealing with it, and there's
Okay.
there's a bit of an art and science to actually doing duct sealing with AeroSeal to do what it can do, and you still have to do what else you have to
Yeah,
do.
taking full
There's
advantage of the technology. Yeah.
Yeah, but as a core element of a duct seal, there's nothing like it, and I've been a fan of it ever since Mark Madera invented it before it even hit the market. I
Oh
remember
yeah.
meeting with him out in Berkeley on this, and actually I offered to work with him to try to bring it to market, but he already had a partner in the field that they would do that, and then they got bought by Carrier pretty quickly, and then Carrier sat on it.
Yeah.
Whatever. But anyway, so the thing is that my view of the opportunity for a company that is involved in understanding all this and doing the diagnostics and the capability is ultimately you need to evolve into a total weatherization heating and air company, and that's that. I think the role of the independent energy auditor, trying to keep his nose clean, that I don't sell anything and all this. Why are you doing it to yourself, guys? If you're listening to this podcast, I'll tell you, let me just say a few words about sales. A lot of guys just think sales is sleazy, and that's absolutely the 180 degrees wrong. Sales is a noble profession as long as you understand that, as Zig Ziglar most memorably taught back in the day, selling is not something we do to our customers. It's something we do for them.
Yeah.
And if you understand that selling is just helping, and selling is service, and your job is to help people guide them to get a project they're going to love, and you should never be ashamed of being more expensive, at least because you're not. That's the ultimate point. That they're paying for a bad job, whether
Yeah.
they buy a good job or a bad job, right?
Yeah.
So anyway,
There's
so
just a lot of education involved too, just being able to speak to
There is.
homeowners about this stuff in a way that they can relate to.
Well, and that's what my second point. I was an accidental entrepreneur businessman by having that entrepreneurial seizure right back when I was in high school, and I've still not ever got a paycheck. Everything I've been paid has been either as a consultant or as an owner. But I then became an accidental salesperson. I had to figure out how do you sell the solution to a problem that people don't even know they got.
Yeah. That's
Well,
like
you got to
yeah.
show it to them,
Yeah.
right? So that's where the blower door and the duct testing and the air tester, air tracer, and all these other great tools are so important. They really do help. So now that does bring us to another problem, though, which is, Sam, relating back to kind of your background. The danger is that every opportunity turns into a science project,
Mm.
and you cannot do free science projects.
Yeah.
Yeah.
Not
And so
profitable. Yeah.
It's
yeah,
easy to
so
get stuck
And that's where I tried to straddle that for 30 years with Retrotec and then Comfort Institute, trying to find that balance between how much can you do for free or for a nominal fee to show that you've got a good handle on this. And because ultimately what Patty taught me was if you don't do some show, you may not get the dough. And so a little bit of show is good, but certainly the air tracer and a good infrared imager are the two tools that I go into every home with. Usually I'll also have a digital manometer as well, but check building pressures and everything else. But pulling out the blower door, pulling out the duct tester, that is one of those things where you try to avoid it if you don't have to. Because, like, for example, with duct leakage, do I really need to do a duct test to know that a 30-year-old duct system is going to probably have 200 to 400 CFMs at 25 leakage? No, it's going to have it. So that brings up another truism that I came up with, which is sales psychology trumps testing technology. Now, it's not to say that the testing doesn't have its place, and absolutely, I'm a big fan of testing in and testing out, which is why the AeroSeal machine, which by the way includes Retrotec manometers built right into it. The AeroSeal machine is so wonderful because it does both at the same time on the job. If you're not doing AeroSeal, then it's criminal not to do a before and after test. And just total duct leakage. The whole blower door duct tester combined together routine. It just seems like too much of an exercise in science, but just measuring total duct leakage before and after. But then that brings up another frustration I had, because I train guys how to do mastic sealing with the best of them. I'm like, I was out there, I've mastic sealed a whole pile of ductwork in my time. And what I found was very frustrating was that way too many guys that I would train to buy the blower door, buy the duct tester, they would sell the duct seal, but they often drifted away from doing the post-test. Unless a utility program required it.
Yeah.
Now, why would they drift away from it? Well, it takes time.
Yeah, sure.
There's a more insidious reason, which is often the results were not what they wanted.
No.
Yeah.
And the AeroSeal, when it got released to the open market, and some of its early teething problems got worked out, Amit has done just a wonderful job making that technology, maturing the technology and making it, I wouldn't say it's like falling off a log, but it's really definitely a very predictable and reliable technology now. Having that in a company's toolbox as a way to seal ductwork and certify the results is awesome. And I recommend that the AeroSeal dealers give a guarantee that if we, typically 80% would be my minimum. I'd say if we don't get you an 80% reduction minimum, then we'll prorate and give you a discount.
Yeah.
And give the customer the confidence that they'll do that. And most of the guys I work with AeroSeal, especially if they capture boot leakage, there's all kinds of testing details. But if you capture boot leakage and you seal boot leakage and you seal the ductwork, 90% plus is routine. It's the norm. It's rare not to get 90%.
Yeah.
So anyway, so as sort of an accidental businessman, accidental inventor, and accidental salesperson, then became an accidental sales trainer, because ultimately the guys that would buy the test equipment from us would say, "This is great, but how do I sell it?" And so, I think we talked when we were getting on your podcast here, what are any regrets I might have, or have we accomplished our missions? I think the Retrotec mission, I would say yes. I think for sure I'm very proud of my involvement, full-time for 18 years and then part-time for another 12 years or so. And then I've been out of it now for over 12 years. But the Comfort Institute and then the Retrotec initially, our attempt to get contractors to take this on, and then the Comfort Institute membership, where we had much more aggressive whole house training for heating and air guys. I would say no, we did not meet our goals, and I do have regrets about that. And probably the biggest regret was trying to bite off more than we could chew.
Yeah.
And trying to fight the inexorable pressures that are on the heating and air industry to sell boxes and to be driven by the weather, and so on. And so those things have been frustrating. I think one reason that we thought we needed to go further in our training and transform heating and air companies to become total home performance contracting companies, that was motivated often by the fact that there were so few good home performance envelope companies out there in most markets. Now that has changed. There's quite a few. There's a lot more insulators that have caught on, and they know how to do dense packing. They know how to do attic air sealing. They can do what I call a suck, seal, and blow, which is most attics. I hate going up into an attic and not taking all that old insulation out.
Oh yeah, it's a must.
Yeah.
Yeah.
And crawl space encapsulation, all those things. There's companies that can do that. And so some of the better heating and air companies I work with now, they do the duct repairs, including duct sealing in-house. They do, of course, the heating and air. They do IAQ products. More and more, they're doing a bit of ventilation. Depends on the market. But the best guys have found a subcontractor to work with to do envelope air sealing and insulation and crawl space encapsulation.
Yeah,
And
that's what I'm seeing too. I mean, a lot of these that are actually being successful with this and selling these types of projects are, I mean, 2 or 3 companies that collaborate together.
Yeah,
to make it
exactly.
happen, because they all usually have their own wheelhouse, so they like to stay in.
Yeah.
You have your heating and air contractor. And sometimes, I mean, we even have a weatherization contractor that does the suck, seal, and blow, but they don't measure. They just use somebody else to do that.
Yeah.
And so, you know, this building science is an interdisciplinary trade. I mean, you have to kind of hit it from all angles. And so sometimes it takes a team to complete one project like that.
And
So,
it's more doable now than it was back in the 90s, in
Yeah.
the 80s and 90s when I first
there's
started.
more of us out there now than there used to be.
Yeah.
Yeah. So I think that we got onto this whole topic by just what can I say to a company that's trying to be a retrofit auditing company? Unless there's a rebate incentive program that's pretty healthy in your market, especially one that doesn't allow you to be a contractor, like doesn't allow you to wear both hats, I would say get over it and learn how to be a solution provider, not just a talker.
Yeah.
And I did it like literally within months, and I don't regret it. And that's actually my only other regret is I should have kept my heating and air weatherization business going.
Yeah,
If I
right.
could have.
Yeah.
Some of the trying to get all the other guys to do it, I could have actually pulled it off.
Yeah. It's always in demand.
Yeah.
No matter where you work.
Yeah,
So-
for sure. So anyway, that's kind of the long and the short of it. So I guess as far as our relationship with me and Colin, full-time partners for like 18 years or so, and then
But what drove the decision to when you finally moved the manufacturing to the States?
it moved. He wanted to move back out to Vancouver. We literally some places in Ontario about 4 feet of snow the other day.
Oh, yeah.
And
Like,
so
so-
he
Not
lived.
a fan
I
of
think he
that.
grew up in Alberta or something, but he'd lived a lot in Vancouver. And so
climate-driven.
he said, "To hell with this." And so it made more sense for the manufacturing. So originally the manufacturing moved to Vancouver for a couple of years on down. It was downtown on Granville Island, I think. It was right downtown.
Yeah, that makes sense.
But then fairly quickly we decided to move it to Blaine and Bellingham,
Okay. Yeah.
and then Queen Street in Bellingham for a long time.
That
and,
happened like in the early 80s then? Like the move to the manufacturing in the States was like in early 80s, 83 or something?
No, I'd say Queen Street was probably around late 80s.
Yeah, okay,
I guess,
late 80s.
probably
yeah.
89, 90. That whole fire protection initiative also just blew up great for us.
Oh, yeah.
So we were just doing all kinds of crazy things. He tested the World Trade Center down in New York. I tested the World
Wow.
Financial Center.
Yeah,
I
there's like
tested
the
the
NASA
Space Shuttle launch
Space Shuttle
pads.
launch pad. Yeah, so like that,
Yeah.
that was in all the promotion and the brochures and everything, whatever.
That's right. And nuclear power plants. I've been in more nuclear power plants than I should probably check myself for radiation. But and then he did a lot of work with the folks over in England, and
Okay.
getting stuff going over there. We were both together working on an NFPA project that actually created the whole protocol for using blower doors to test data centers, and basically instead of doing the environmentally unfriendly dumping of halon and that sort of
Oh,
thing.
yeah.
So
Yeah.
that distracted us for a while.
Then like
But,
who approached who really like for the enclosure integrity market? Like was it something that you guys found that was an opportunity or something that just the phone rang?
Yeah, no,
and I was like,
one of our clients in Ontario, I believe, was doing construction work for a data center. I think it was in Toronto area, and they were having this data center had halon 1301, and they had already dumped it once and failed the discharge test. And the contractor said, "Oh yeah, no." The contractor was a buddy of one of our clients, and he said, "I know this guy that's got this machine that finds leaks.
oh, wow.
We should have him come in." So the engineer said, "Well, sure." So we brought him in. They did a blower door test, probably the first one
Okay.
on a data center. And the engineer, what's his name? He was an NFPA committee member and pretty connected. And he had the light bulb moment. He said, "This is good." And
Yeah.
and the first thought was we should always do this test before we dump. But then, but then the Montreal Protocol came along and said, no, this is not okay to be. Because Halon 1301, I think it was 200 times more potent from a ozone depleting standpoint than R22.
Okay.
So, which is
Wow.
a residential refrigerant, and probably 20 times worse than R12. So it was pretty clear that this dumping 1301 just to test how tight the room was
Yeah.
kind of stupid.
Still, yeah.
Yeah.
So anyway, he got involved with all that, and I'm very proud of that work that we did to accelerate the. We did a big project. It was funded. A lot of the funding actually came from Northern Telecom, Bell Canada. They contributed money
It's for like their telecom rooms to test out all their telecom.
because they had so many of them. Yeah,
Yeah.
so we did all the tests. We actually did do dump tests with 1301 to do comparisons and prove that a blower door prediction would always be more conservative than a 1301 test. And so we came up with a whole protocol for using the blower door to calculate a worst case decay of the gas, and then other functional tests on the equipment and the alarms and all that. And it became accepted by the insurance industry, and it's become the norm now. That was, again, 30 years ago. So a lot of fun.